Hello friends, in today's video, I am going to teach you the partial differentiation of composite function. Here I am going to tell you the meaning of composite function, and even I am going to teach you how to manage the partial differentiation of composite function by using simple and unique method. So let's learn the partial differentiation of composite function. In composite function, there is a first function, that is u equals to f of r. This is the first part of the function, but again r is a function of other two variables, like u is the function of r and r is the function of two variables x and y. So this type of function is nothing but composite function. So composite function is a function of function. For example, suppose we deposit money in the bank. The money deposited in the bank will depend upon profit of the day. If more profit, more money can be deposited, and less profit, less money can be deposited in the bank. But the profit of the day will again depend upon the two factors, like number of customers used our product, number of customers purchased our product. So let us call it as X, and number of working hours. If you are working less hours, then the less customer visit and the less profit will be there. So profit of the day will also depend upon number of working hours. Let us call it as a Y. Let us call money deposited in the bank by the letter U, and profit of the day by the function of f of r. So we got u equals to f of r is the function, and the r again depending upon the two variables x and y. R depends upon x and r depends upon y. So u equals to f of r, u depends upon f of r, and again the depends upon r depends upon two variables x and y. So this type of the function is nothing but called composite function. So u depends upon r, so u is a function of r, and again the r is a function of x, and again r is a function of y. So u is the function of r, so u equals to f of r. Again the r is a function of two variable x and y, so r is a function of x and y. R equals to phi of xy. Now we wish to find the partial derivative of u with respect to x, or else you want to find partial derivative of u with respect to y. So how to find the partial derivative of u with respect to x? How to find partial derivative of u with respect to y? This can be obtained by using chain rule of partial derivative. That is, if you wish to find the partial derivative of u with respect to x, first you have to find out partial derivative of u with respect to r, because u depends upon r, but r also depends upon x. So you need to find the partial derivative of r with respect to x. So there are the two steps involved to find partial derivative of u with respect to x, that is partial derivative of u with respect to r. Therefore del u by del r multiplied by del r by del x. So this way you can find out partial derivative of u with respect to x. Or you wish to find partial derivative of u with respect to y. First you have to find out, partial derivative of u with respect to r, because u directly depends upon r, but r depends upon y. Therefore the partial derivative of r with respect to y. So to get the partial derivative of u with respect to y, we have to carry the two steps. First step, partial derivative of u with respect to r multiplied by partial derivative of r with respect to y. So this way we can do the partial differentiation of composite function. To enhance our understanding, let us take some few practical examples. For example, if u equals to log r equals to under root of x square plus y square, find partial derivative of u with respect to x. So solution, here u is the function of r and r is again the function of x and y. So if you wish to find partial derivative of u with respect to x, then first you have to find partial derivative of u with respect to r. So I am having u equals to log r. Now partial derivative of u with respect to r, for that differentiating both sides with respect to r. Here we are doing partial, so differentiating partially. Differentiating partially both sides with respect to r. So we get dou u by dou r, that is del u by del r with respect to, that is partial differentiation of log r with respect to r, that is equals to 1 upon r. So call it as the equation number 1. Now r we are having, r is nothing but under root of x square plus y square. You need to find the partial derivative of r with respect to x. So partial derivative of r with respect to x is nothing but 1 upon 2 under root of x square plus y square multiplied by 2x. 2 get cancelled here, x upon under root of x square plus y square. If your derivative is not strong enough, then please visit my playlist. In that one, I have solved so many problems, so many episodes. So you can go and learn how to do the derivatives by using chain rule. Come back here. So I am having partial derivative of u with respect to x. I got this one and this is the second. So I need to multiply both the results. Dou u by dou r, that is del u by del r, equals to 1 upon r multiplied by del r by del x, that is x divided by under root of x square plus y square. Now putting back the value of r, that is nothing but r equals to under root of x square plus y square multiplied by x upon under root of x square plus y square, which on simplification gives dou u, that is del u by del r, partial derivative of u with respect to r, equals to x upon x square plus y square. Example 2, if u equals to r square, where r equals to xyz, then we need to find del 2u by del x2 plus del 2u by del y2 plus del 2u by del j2. Addition of all this. Solution, we have u equals to r square and r is the function of 3 variables x, y, z. So to find out del 2u by del x2, we have to find out the partial derivative of del u of del x with respect to x. Del u with respect to x, that is partial derivative of u with respect to r multiplied by partial derivative of r with respect to x, that is equals to partial derivative of r square with respect to r multiplied by partial derivative of r nothing but xyz with respect to x. So this is equals to 2r, and here y and z are constant, so I have taken them outside of operation. Then partial derivative of x with respect to x equals to 2r multiplied by yz multiplied by 1, so that is equals to 2ryz. Now, to find out the second derivative, that is del 2u by del x2, we need to do the differentiation again of resulting, that is 2ryz with respect to x. So here y and z are constant. So 2yz taken out of operation. Now partial derivative of r with respect to x. This is equals to 2yz. r is nothing but xyz. So partial derivative of xyz with respect to x. This is equals to 2yz, and again yz taken out of operation. We have to do the derivative of x only with respect to x. So 2y square z square multiplied by 1. Therefore, second order derivative of u with respect to x, that is del 2u by del x2, is equals to 2y square z square. Similarly, we will get second order derivative of u with respect to y is nothing but 2x square z square, and with respect to z, del 2u by del z2 equals to 2x square y square. Now we need to find the addition of all the three, because here the question was demand that find the addition of all these three. Therefore, del 2u by del x2 plus del 2u by del y2 plus del 2u by del z2 equals to 2y square z square plus 2x square z square plus 2x square y square. So taking 2 common, we get y square z square plus x square z square plus x square y square is required solution.